A critical part of performing u substitution is making the correct choice for u. Let's talk about how to do this and then also how to find du. Here's the steps to integrate with u substitution. The first step is to make the correct choice for u. Then you have to find du. Let's talk about how to do these two steps. First, how to make the correct choice. An important clue is whatever you choose for u prime has to appear somewhere in what you're integrating. Here's our first example. Take the indefinite integral of this function. We know we can't use our normal antiderivative rules since this is division of two functions. However, we might be able to do a u substitution that would work. If that were to work, what choice should we make for u? That's the first thing to figure out. Now maybe you think, oh, maybe we can make u be 2x. So we must determine if this is a good choice for u or not. The key is make sure that u prime appears somewhere in what you're integrating. In this case, u prime equals 2, which we do see here, but you have to think about what would you get rid of if you make that substitution for u, and would it be something that you know how to integrate? In this case, it wouldn't help us very much. It wouldn't get rid of very much. It would just get rid of this 2x, replacing it with a u, and then we still wouldn't know how to integrate the result. So the answer is no, this is not a good choice for u. Let's try a different value for u. What about u equals 1 plus x squared? Is that good? Well, let's find u prime. U prime equals 2x. Do we see that in our integrand? Yes, right here. That's a good sign. Let's check and see if this would work. For this to work, when we substitute in for u and for dx, we have to have something that we know how to integrate. The next step is to find du and make the appropriate substitutions. Du equals u prime times dx. In this case, u prime equals 2x, so du equals 2x times dx. Now we need to solve this for dx so that we can replace dx in our integral with what it equals in terms of u. We solve this for dx by dividing both sides by 2x. So we get dx equals du divided by 2x. So now we have to make our substitutions. First, we have to substitute in the value of dx. Dx equals du over 2x. Then we plug in the value for u. U equals 1 plus x squared. So we replace this value with u. We've now made those substitutions. Now look what happens. This 2x's can cancel, leaving us with this integral in terms of u. The question is, do we know this antiderivative? And the answer is yes. It's ln of u. And then for the final step, we put the answer back in terms of x, so replace u with what it equals, which is 1 plus x squared. So we get ln of 1 plus x squared plus c is the antiderivative of this function. This was possible because we made a good choice for u. Let's go back to our original choice. U equals 2x. Would this would have worked? No, it wouldn't have. Let's see why not. With this choice of u, du would have equaled 2 times dx, which we solved that for dx, giving dx equals du over 2. Now let's make the substitutions. U equals 2x, which is this. This becomes u. And dx equals du over 2. Now look what happens. We still have an x inside our integrand, and we don't know how to take the antiderivative of this function, so we're stuck. So that's why u equals 2x was not a good choice. Let's look at another example. Let's try u substitution because we don't know how to take the integral of this. Also, u substitution is a good idea when you think it looks like the chain rule may have been used to take the derivative of the original function in order to get to this function. So in this case, it looks like 2x squared plus 3 would be a good choice for u. The reason that looks like a good choice is because that looks like that may have been what the original inside was. Let's find u prime. Is u prime present in the integrand? Yes, it's right here. So that's a good clue that u equals 2x squared plus 3 is a good choice. Now let's find du. du equals 4x times dx. Let's plug this in and see if this is going to work. First we have to find dx by dividing both sides by 4x. Now we're ready to make our substitutions. Dx equals du over 4x, and 2x squared plus 3 equals u. We've made our substitutions. Notice we can cancel these 4x's, resulting in this. The question is, do we know how to take this antiderivative? The answer is yes. This is just a simple power function rule. So that means since we know how to take this antiderivative, this was a good choice for u. And we could proceed and finish the question. But right now I'm focusing on how to make a good choice for u. Let's look at another example. In this example, we're taking the integral of this function. What should u equal for this one? You might think maybe 3x, since that seems to be like the inside of ln. Is this a good choice? Well, since u prime equals 3, I don't think so. Because I don't see u prime in here other than this, but this will be replaced by u, so there's nothing else for u prime to cancel out with. So that's probably not a good choice. Let's choose something else. What about ln of 3x? Well, let's find u prime. U prime equals 3 over 3x, which just equals 1 over x. Do we see this in our function? Yes. This is an equivalent form of our function. We could write it like this instead. And we see 1 over x right here. So yes, this is probably a good choice. Let's make the substitution and check. In this case, du equals 1 over x times dx. Let's solve this for dx by multiplying both sides by x. And we get dx equals x times du. Let's make the substitutions. First of all, dx gets replaced with x du. And ln of 3x gets replaced with u. We made our substitutions. Notice this x and this x cancel, giving us this. The question is, do we know how to find the antiderivative? Yes, this will be very easy. That means it's a good choice for u. Let's look at one more example. First question, what should u equal? It looks like maybe x squared would be a good choice for this one, since that still looks like that might be in their original inside. Let's find u prime, which is 2x. Do we see this in our integrand? We don't see the 2, but we see the x. The 2 is not that big of a deal. The x is what we're looking for, and we do see that. So that means this is probably a good choice. Let's make the substitution and see if it's going to work. Du equals 2x times dx. Let's solve this for dx. Now let's make our substitutions. First, dx equals du over 2x. Then u equals x squared, which is right here, so this becomes u. Now what can we simplify? Well, we see these x's, they cancel, leaving us with this. Now, do we know the antiderivative of this one? We can rewrite it like this. 1/2 is just a constant, so we can put the 1/2 out front, outside of the integral. Do we know the antiderivative of this? Yes. It's just e to the u. So if it's just a constant, you can move that out front. If there's an x in that with that factor, then that leads to a problem. So in this case, it's going to work. So this is a good choice for u. So in this video, we saw how to make the correct choice for u for a variety of examples.